Data analytics on a dime. Sounds bad, but is it? The truth is, most companies, in my opinion, overspend like crazy. They have no idea that the recommendations that they're getting from consultants and vendors are probably out of line, excessive, and really geared towards getting that customer's money in that vendor or consultant's pockets, and not really geared at helping them be the most efficient with their money to get the analytics that make sense for the business. One of the biggest places that you can find yourself overspending like crazy is with data engineering. Data engineering is just expensive. First of all, from a labor standpoint, it's a highly skilled position. And most companies that get very far into analytics and really begin to build quite a bit wind up with more than one data engineer. So you may wind up with a department or a group of data engineers and a data engineering manager. All of those people are highly skilled and extremely expensive. So their time is money, and that money adds up really quickly. Um, there's a lot that you can do with reusing code. And one of the biggest things I find to make just a huge impact on how much gets done from a data engineering standpoint is dynamic, data driven ETL. So, most of what data engineers do is ETL. They go connect to whatever sources have the data, extract that data, transform it, make it look the way it should look, remodel it so that it works well for analytics, and then load it into another environment. I'm going to show you how we can use dynamic, data driven ETL to take at least one big chunk of what gets done in ETL and make it very fast, very efficient, very reusable. Basically, with a couple of stored proc calls, you can take care of the first several steps of doing your data engineering work. Now, this code is not trivial. It's not something that you're going to throw an intern or a junior developer who's not long out of college at. It's fairly sophisticated code, but a really sharp developer should be able to build all of this within a week or two, and it will save hours and hours and hours of data engineers' time, um, week after week after week. In addition to that, it will greatly reduce the spend that you have on all of the software components that do the data engineering. A lot of those are cloud components. Oftentimes, data engineering work requires more than one of these components to be running at a time, and they all charge by the second for every minute that they're doing any work. So, being able to get that done very quickly and efficiently with very little effort is going to save you a ton of money. So, let's take a look at it. Okay, to make all of this work is only going to require a couple of tables and about three stored procedures. Once that's built, your data engineers will be able to call stored procs with a few parameters, and then from those do light transformations, pull the data out of a source system, drop it into the data lake or blob storage or wherever you're landing your data, and then automatically have that get pulled into a data warehouse of whatever sort you're going to use. In this case, for this demo, we're going to be using Databricks, but all of that will be handled automatically. Additionally, this isn't just one kind of data. This will include merge data, which means insert, update, delete data. It'll include append data, which would just be maybe log file data where, it's just going to constantly, as new data comes in, it adds new data, but it will keep track of exactly which rows have been added and haven't been added, which files have been processed and haven't been processed. It will take care of streaming data. It'll take care of CDC data. So we're going to basically be able to take care of all different kinds of data with just a few procs, and a call to each of those procs with a parameter will pretty much get everything going. So let's take a look at it and see what we have. Okay, before we actually run any of this, I want to take you out and show you where the data is going to land in Azure, and I want to show you what it's going to look like in the data warehouse that we're going to load it. I'm going to make sure that there's no data in there now so that we can see it actually appear there. So this is where we're landing the data. And let me go back up to my staging area. And in this staging area, it's going to land everything in this directory structure under data lake objects. The way that I've built this, it takes the source database that all of this is coming from and lands everything in a folder with that name, and then appends the table name together with the source schema name so that you can keep track of where all your data came from as you're loading it into the warehouse. So this is what it all looks like. We're going to delete all of this so that you can see it all appear really from scratch. So we'll take this whole folder and we'll click delete. And then after we run the update or push the data out, we'll be able to refresh and see that come back. First of all, we're going to go to the right database. In this case, we've got all this in a data lake objects database. Something I want to point out here, this is all being done on an on-prem RDBMS. In this case, it's SQL Server, and I'm using Developer Edition, which means this is free of charge to build for anybody. This is a free relational database management system for anybody who wants to download it off the internet from Microsoft and use it. So this costs nothing, even in production. If I have an RDBMS anywhere in my company, I may be able to use that in production to build all of this stuff and not have to pay anything that I haven't already spent the money on. Okay, so let's look at when we copy this data out to the cloud, we're going to need to have credentials. In this case, we're storing credentials in a table. Here's our container path, here's our target schema, and here's our SAS token. In this case, we've explicitly denied access to everyone, to public basically, against this table, which means nobody can view or modify this except a system administrator. Okay, the next thing we're going to look at, we're going to go ahead and clean this up so that we're going to start from scratch. We're going to get rid of any views that may already exist out there with this data in them, and we're going to get rid of the control table that controls all this so we can build this all from scratch, and you'll watch every step of it. So this gets rid of our views and our table control table. And this is what we're going to do to basically set up our data-driven ETL. This is our first table. This is going to be defined as an overwrite table. The name of the table is product. The schema for the table is stage. And that basically means this is going to be a trunk and load table. That means this is done. This is ready to go. Right now, this can be pushed out to the data lake. The next table that we're going to deal with is a merge table. This is an insert, update, delete table. Every time data is pushed out to the cloud, it will automatically allow this to be inserted, updated, and deleted. It will keep track of the primary key, and it will keep track of the starting point of that primary key. And every time new data comes in, it'll recognize that this is new data. If data comes in again that's already been put in the table, it will update that data based on this. So we'll execute this. This is the third table. This is an append only. What you might see is a log table. And this one is specifically a date dimension. So we're going to say, hey, anything that's in that table that's more current than 1980, we want to push that out. It will, as soon as it pushes that date out, it will record the greatest date that's been pushed and then only push from this point forward any date later than that. Also, all of these tables, you may notice these yeses and nos and this number at the end. What we do is we put this in an automated schedule that runs almost constantly, and then that process that runs determines, is this data that we need to push during the weekday, during the weekend, during the daytime hours, during the nighttime hours, and how many minutes do we want to put between pushes? So in this case, because this is a date dimension, we don't want to push it that frequently. So every couple of hours, if anything's changed, it pushes only the changes out. Oops, did I run this? I don't know if I did. Must not have. Okay, and then this is the last table we're going to do. This one is a streaming table. It's going to run every 5 minutes, and this is a streaming demo. You probably, from real streaming data, would run this very, very real time. But the data warehouse that we're going to push this into will handle massive amounts of streaming data coming in very, very fast. This is really just for demo purposes. So that's it. Now, this is some other tables data for different demos, not really relevant here, but it's just there because I didn't want to completely delete it. Now let's look and see what we did. So when we ran that 4 proc calls, this is what it did. It loaded these 4 rows into this table. This is going to define our source and our target. It's going to define the names of all of the tables, both in the source and the target. It's going to tell the system on the other end, the data warehouse, hey, you need to be overriding this data, merging this data, appending this data, streaming this data. I don't have it in this example, but CDC data works just as well. And then it'll say, okay, you need to start at this point and apply future data. In this case, this is starting at -2, and this is starting at this date. Then notice here, this is how often it should run. So every time this process runs, it can look and say, was it ever executed? If so, when was the last time it was executed? I need to wait this many minutes before I execute it again. So now, let me move this down so we can see it a little bit better. We're going to actually push this data out to the cloud. And what I want to do is change this from this grid output to a text output so you can see what it's doing. And we're just going to run these all at once, one right after another, all 4 of these. And we're telling it, hey, only grab this many rows. I only want to grab this many rows at a pop. And this is all of the tables that we just set up. So when we run this, you can see that it started copying rows. I should point out this is running on a pretty underpowered laptop. It's pretty old, it's pretty underpowered, and that's it. It has pushed all of that data out to the cloud. Okay, the next thing we want to do is go out to Databricks and make sure that none of this data already exists out there. Okay, so we'll go out here and we'll drop, just in case they already exist, each of these tables. That one did exist, so it dropped it. That one did exist, so it dropped it. And that one did not exist. Okay, so if we look now at those tables and try to query one, we're going to get errors on all of them saying that they don't actually exist. All right, so we're good to go. Let's go back to our relational database and finish up. Okay, a couple quick things I want to show you real quick. First of all, this is what this looks like now when we look at our table control table. Let me put this in grid so it's a little easier to see. And I'll move this up so it's a little easier to see. So again, these are our tables just like before, but notice now it's got new values. It's got a new watermark that says we've copied everything up to this number. So anything greater than this number we'll copy. We've copied everything up to this date. So the next time it runs, it will only grab dates higher than this. And we've copied up to this number in this table. Also, this will only run for these tables at the specified times. So this initial table will never run again because it's weekday, weekend, day, night. They're all configured for no and no frequency It's just as long as it's ever been modified. So if you want to run this one again, you'd set that value to null and it would rerun again. On the other ones, like this table will only run during the weekdays and it will only run during the daytime. So nights and weekends, it will not run. This one will run during the weekdays and on the weekends, only during the daytime, but not at night. A reason you might want to do that is maybe you run database maintenance at night and there's just too much contention for these things to process well at night. So you have them turned off. This one is the one that we're using to kind of simulate streaming data. This one would probably run much more frequently and it would run day and night 24/7. And quite honestly, normally for streaming data, you're looking at something that's really absolutely constant. It's not like every minute or a few minutes or something like that. So the other things I want to show you, the three procs that do this work, and they're not long, but they are fairly complex. There are a lot of sort of nested dynamic SQL. They take a number of parameters. This is the proc that we called to make the views and load the tables. This was the first one that we called. And basically what it does, it goes out and determines what kind of table are we looking at. Are we trying to build one for CDC, for append, for overwrite, for merge? And it goes out and it figures out all the different columns. It does do some minor transformations. It does things like removing embedded spaces and making everything lowercase. We're pushing this all out to blob storage and it's all case sensitive. So it's just so much easier to work with if you don't have to fight with the fact that here we made the database name with a capital first letter and there the whole database name was capital and somewhere else it's all lowercase. So we just hard set all of the data and all of the columns and all of the tables. Everything is lowercase. And this is just an option, but in this case, this is what we wanted. The next proc this is the proc that we call, and again, we've already called this one as well, to push the data to the cloud. And it takes a handful of parameters, and it also uses the table that we created to look at each table that needs to get pushed that we've called this for and get the additional information that we don't pass in with these parameters. That way we don't have to try to pass in for every proc call, 150 different parameters. It's all kind of table driven. So it goes out and it determines, hey, what kind of table is this? Is this going to be a overwrite trunk and load table? Is this going to be an append table? Is this going to be streaming, a merge, a CDC table? All of these are defined. And again, these all use very, very cobbled together dynamic SQL. So it's not something that somebody who's not very experienced with this SQL would be able to do very easily. But if it's an experienced SQL developer, this is something that any real quality data engineer could do fairly quickly and fairly easily. And the key to all of this is making it fairly simple. This may not look simple at first glance, but it's not a huge long proc considering that it accommodates overriding data with trunk and load, appending, merging data, CDC data, streaming data, handles all of them differently. So it's fairly short for what it does. And then this would be the proc that would go inside of a job or some sort of an automated task or process. This is going to go through and loop through the table that we've built and get the additional parameters that need to be passed to the proc that would push everything out to blob storage. So this is what that looks like. It's not very long. It's not very complex. This is literally all the code that's required to make this work. All right, so let's go out and see what we've got in our storage account. When we go out to Azure, again, we've pushed data out, but we haven't refreshed yet. So when we click refresh, we should see a new directory show up here, Data Lake Objects. And if we go in there, we should see all of our data that we've pushed. Customer data, date, product, reseller data. And if we go into those, there'll actually be CSVs with that data that we need to load into Databricks. One more thing worth noticing there should be a file out here that tells Databricks how to process these. We haven't run that yet, so let's go back and run that. At the very bottom of all of this, here's the code that would normally be run in that job as well as the other proc that takes this table. Every time it runs, it pushes the table out to tell the warehouse on the other end of this process, this is how you need to process this data. This is what's been processed up till now, and this is what you need to do with it, whether you need to append it or merge it or trunk and load. So let's go ahead and run this. And go back out and see if that has landed. So when we click refresh, there's that table. Okay, so we're back here at Databricks again, and let's go ahead and run this notebook that should process all the data we've pushed out to Azure. Scroll down to the bottom and look at the output. There's product, there's customer, there's date, and there's no errors. So we'll go over to the notebook where we have queries against that data. And there's our product data. There's our customer data. And there's our date data. So again, we've handled all different kinds of data, and we've pretty much processed it all automatically. This would all be automated in jobs. We didn't do it in jobs so that we could walk through step by step and show you what it looks like. But the reality is, with this type of a system, a data engineer only has to hand the parameters to a stored proc call that loads a table, and from that point on, the data gets at least some degree of transformations, gets extracted from the source system, gets loaded into the data warehouse, and in an automated fashion continues to keep that data updated automatically, all by data-driven ETL.